Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today I want to discuss a topic of differential equation, non-exact differential equation. So in this chapter, non-differential equation, there are several methods to test the differential equation is non-exact or not. So one by one I have discussing all methods, but this is last method of non-exact differential equation. How we can check a differential equation of first order and first degree which is non-exact. So this is last method and very interesting method. So method 6 type of the non-exact differential equation is x to the power here. This is the type of differential equation. This equal to 0 here. So x to the power m, this is the type of differential equation here, general differential equation, and x to the power m is number here, and y to the power n, there is multiply with this element, and in bracket is ay dx plus bx dy. A and b are here constant, plus x to the power m dash into y to the power n dash. M dash and n dash are some constant, means x to the power sub here and y to the power here. So this power and this power are different here. And in bracket a dash y dx plus b dash x dy equal to 0 here. So this is the basically general equation of this method. If our differential equation is same this type, then we apply method 6. How we can apply in method 6? So I am discussing detail in this method. Equation 1, this equation 1, I am considering equation 1. The equation 1 can be written as, we can write this equation is simplest type. Simplest type means here is only function of x and y into dx, and next function of x and y and dy equal to 0. This is also equal to 0 here. So here is dx and here is dx. First term is dx and third term is dx. So taking dx is common here. We are taking here dx is common. And now multiply by x to the power n and y to the power n. This function multiply to this term. So we get here a x to the power m and y to the power n plus 1. Here is y to the power 1. So we are adding y to the power n plus 1. Plus next term is this x to the power m a dash x to the power m dash and into y to the power n dash plus 1 here. N dash plus 1 into dx, plus similarly x to the power m multiply here. So x to the power m plus 1, v into x to the power m plus 1 and y into n plus next here x m dash plus 1 and y to the power n dash dy. So this is the general form of the equation. Now solution procedure. How we can solve this differential equation? So we are giving here procedure first. This is the general method. So what is procedure here? Now I am giving step 1. In first step, types of the equation 2 is given as. I am writing equation 1 in the type of 2. Then 2 is becomes this type equation, m dx plus n dy. Okay. So now step 2 here, the given differential equation is non-exact. If equation 1 given, general equation 1 is a non-exact, so it is not verify the condition of an exact. Means this condition is not equal. If this is the condition of an exact, if this condition is not equal, then a given differential equation is non-exact. Okay. So step 3. Step 3 is, here we consider that now we are making this given differential equation is exact. So we are considering some integrating factor. So here we consider that x to the power h into y to the power k. This is some function of xy, x to the power h here and y to the power k, is an integrating factor of 1, equation 1 or 2. 1 or 2 are both are same. So this is the integrating factor I am considering. Step 4, multiply by this integrating factor x to the power h into y to the power k to the given differential equation. Then differential equation becomes an exact. Any differential equation given to you, we are discussing this process in each method, but this is last method. So here any differential equation is given to you and any function, if we multiply to the given differential equation and differential equation becomes an exact, means this function is known as a integrating factor, becomes an exact, and verify the condition of this. If this condition verify after multiplying this function, then this function is known as a integrating factor, integrating function. Step 5. Now, in step 5, after verifying the condition of an exact, this verify, then find value of h and k here. Okay. We have given unknown function. There is some power of x is h and y to k, y to the power is k. So h and k are unknown here, but we are taking x to the power h and y to the power k as an integrating factor, and we multiply by this factor to the given differential equation. And now differential equation, we are verifying this condition. After verifying this condition means given differential equation is an exact. Now step 6. Now putting value of h and k, then solving by exact method, because we have confirmed this is an integrating factor. Multiply by confirmed integrating factor, then differential equation is an exact 100%. Now problem 1. I have discussing only here one problem based on method 6. So this is the same question which I am discussing, just general method. So problem 1 based on method 6. Solve y cube minus 2x square y dx. Y cube minus 2x square y dx plus 2xy square minus x cube dy equal to 0. This is the given question, problem given us. Now solution. First of all, I am writing this question here. Y cube minus 2x square y dx plus 2xy square minus x cube dy equal to 0. This is equation 1. I am considering that question which is given in problem, that is considering equation 1. Writing the given differential equation 1 in standard form. Standard form means which I am discussing just in method. So now how we can write this? Y cube, first term of this term, y cube dx, multiply by dx, y cube dx, and next 2x second term, third term of first term of second, 2xy square dy here. So here y cube dx plus 2xy square dy plus, now second term, minus 2x square y dx, and next last term minus x cube dy here taking. This equal to 0. This is the equation 2. Y square taking is common here. So after taking this term y square is common here. Y square taking common, then in bracket we get y dx plus 2x dy. And in next bracket x square is common. Then taking x square common, then minus 2y dx minus x dy equal to 0. This is equation 3. So equation 3 is in standard form. I am writing below, I am writing an standard form of a differential equation which is applied in method 6. So what is standard form? X to the power m into y to the power n, in bracket ay dx plus bx dy. Okay. plus x to the power m dash and into y to the power n dash in bracket a dash y dx plus b dash x dy equal to 0. This is the standard form. So our given equation number 3 is same as this. Here x to the power m. Comparing this is the same or not? So x to the power m, x is not here. So m is 0 here. Y to the power n, y to the power means n is 2 here. Now other result a is 1 and b is also 2. Now x to the power m, m dash is 2, n dash is 0, a dash is here minus 2 and b dash is minus 1. Okay, so these are coefficients we are taking constant in this equation 3 we getting here. So this is the same equation number 3 and equation this is general equation 1, both are same equation. So same process we apply in this question. Now step by step we are solving this question. So step 1 here, verify that equation 1 is an exact or not. The equation 1 which is given in the question, verify that equation 1 is an exact or not. So comparing equation 1 with m dx plus n dy equal to 0. This is the general equation. This is the type of the equation which is exact. If we are checking any differential equation which is exact or not, then we are comparing with this m dx plus n dy equal to 0. This is equation 4. Then we get. So now equation 1 is this and equation 4 is this. Comparing in 1 and 4. So I am writing here one equation. What is 1? Y cube minus 2x square y cube minus 2x square y dx and plus 2xy square minus y cube dy equal to 0. X cube here. This is x cube, not x cube. So this is equation 1. I am writing here. Last page. This equation 1. I am writing in next page here. This one. Y cube minus 2x square y dx plus 2xy square minus x cube dy equal to 0. This is same type, m dx plus n dy equal to 0. Okay. So comparing this is one equation. Comparing with this 4. Then we get value of m here. We find the value of m. Y cube minus 2x square y. Y cube minus 2x square y is the value of m. And this is the value of n. N equal to 2xy square minus x cube. This is the value of n. In our question, value of m is this and value of n is this. This is equation 5. So now differentiating with respect to x, with respect to y, to m with respect to y and n with respect to x, then we get. Now if we get the value of m from the given question and value of n also from the given question, then we differentiate of m with respect to y and n with respect to x. Then we get here. So now del m over del y. This is partial derivative. Differentiation of m with respect to y. Here x as a constant. X as a constant. In partial derivative, if we are differentiating with respect to y, then keeping x as a constant. So now del m over del y. What is del m over del y? Here y cube. Differential of y cube is 3y square. Here del over del y of x cube. So differential of y cube is 3y square. Okay. So differential here y cube. Y cube is 3y square. And now differentiation of 2x square y with respect to y. So differential of del over del y of 2x square y. So x is constant here. Y differentiation of y is 1. So here is 2x square. So differential here is 2x square y. So now del m over del y is equal to 3y square minus 2x square, and differentiate n with respect to x here. We'll be differentiating n with respect to x here. Y as a constant. Y as a constant. We are keeping y as a constant when we are differentiating with respect to x partially. So what is n? N is this 2xy square. 2xy square differentiating with respect to x this. So x is differential of x is 1. Differential of x is 1, so 2y square, and here minus x cube. Next term is x cube. So differential of x cube is del over del x of x cube here. So this is 3x square. So now we get the derivative of del n over del x is equal to 2y square minus 3x square. Okay. So this is equation number 6. Here we see that del m over del y, this value, this is the 3y square minus 2x square, and this is the 2y square minus 3x square. Here is number is changed there. Del m over del y 3y square minus 2x square, and del n over del x 2y square minus 3x square. So number is interchanged. So del m over del y is not equal to del n over del x. So this is the condition of an exact is not verified. In this question, the condition of exact is not verified. So given differential equation is non-exact 100%. If any differential equation is non-exact, we have checked with the property of exact, condition property of exact, we check the differential equation is non-exact. So first we want to make a differential equation exact. We make a differential equation as an exact. So how we can make a differential equation as an exact? So we are considering some integrating factor. That is the function of x and y. That is the function of x and y, and that is an integrating factor. So what is integrating factor? We multiply by a function to our given differential equation, and differential equation must be exact. Then function is known as a integrating factor. So here in next step 2. In step 2 now, taking integrating factor, we are here considering some function in x and y. So that function is x to the power h and y to the power k. I am discussing just in method. Integrating factor equal to x to the power h and y to the power k. Now step 3. What is step 3? Multiply by this the integrating factor in equation 1, then we get. So equation 1 is means in our question, the question is given, that is equation 1. So multiply here equation 1, x to the power h and y to the power k, multiply this function y cube minus 2x square y dx plus x to the power h and y to the power k, also multiply here 2xy square minus x cube dy equal to 0. This is the question. This and this is the question. Here we are multiplying by this function in each term. So this is, I am considering this is an integrating factor. So multiply by in each term by this factor. After multiplying by this factor in each term, then this equation 7 must be an exact, and this also verify the condition of exact. So now after multiplying here x to the power h, here is no x, in this term is no x. So multiply x to the power h and into y to the power k into y to the power 3. So y to the power k plus 3 minus 2 here x square, and here is x to the power h. Multiply x to the power h to x square. So we get 2x to the power h plus 2, and here y to the power k, and here y to the power 1. So here y to the power k plus 1 dx, and plus next multiply x to the power h and y to the power k in this function. Then we get 2x to the power h into x to the power 1, total power x to the power h plus 1, y to the power k and y square here, Then total power y to the power k plus 2 minus x to the power h plus 3. How we can get here x to the power h plus 3? Because here x to the power h and x to the power 3. So x to the power h plus 3. What there is no by, only x cube is there. So multiply x to the power h plus 3 into by to the power k dy. This equal to 0. Okay. So this equal to equation number 7a. Okay. Now this is 8 equation. Here is given equation number 8. Now equation 8 is an exact. The equation number 8 is an exact, and verifying the condition of an exact, del m over del y equal to del n over del x. 100% this condition verify by the equation 8. So now first we are verifying the condition here. So comparing this equation 8 with m dx plus n dy equal to 0. This is the general equation of an exact. So this is same equation is this. So comparing this to this. So we get value of m and value of n here. So now m equal to here comparing. So what is value of m? M is this. Value of m is x to the power h and y to the power k plus 3. This is the value of m, and minus 2x to the power h plus 2 y to the power k plus 1. This is total value of m. This is total value of m here. And n. This is the value of n. Okay. 2x to the power h plus 1 and y to the power k plus 2 minus x to the power h plus 3 y to the power k. Last here given equation number 8. This is the 8 equation after multiplying by integrating factor, and this is the general equation m dx plus n dy. This general equation and comparing with equation 8, then we get value of m and value of n here. Now again differentiating m with respect to y, differentiating m with respect to y, and differentiating n with respect to x, we get, okay, because here we want to prove the condition of an exact del m over del y equal to del n over del x. This condition must be verified. Y, m and n this. Okay. So we are verifying this condition. So now differentiating m with respect to y and differentiating n with respect to x. So we get here del m over del y. Differentiation of m with respect to y partial, x as a constant, x as a constant. So now here x to the power h is constant, x is constant, so I am keeping this constant. Y to the power k plus 3. So derivative of y to the power k plus 3. So k plus 3 y to the power k plus 2. Del over del y of y to the power k plus 3. So this is the k plus 3 and y to the power k plus 2. N x की power n minus 1. We are applying here formula, derivative formula del over del x of x to the power n. So formula is n x to the power n minus 1. This formula we applying here. So now here n minus next 2 x की power of x h plus 2 and differential with respect to y to the power k plus 1. So k plus 1 x by to the power k plus 1 minus 1. So by to the power k. And del n over del x. Differentiation of n with respect to x here. So y as a constant here. Y as a constant here. So now differentiating of this function n with respect to x. Y keeping constant. No change in y element. No change in function of y. Only function of x is changed. Differentiation formula. So here y is constant k plus 2. I am keeping constant this, and differentiating x की power x h plus 1 with respect to x. So h plus 1 x to the power h minus h plus 3. Here differentiating this x to the power h plus 3. So h plus 3x to the power h plus 2 and y to the power k keeping constant. So this result is y to the power k. So the both derivative are taken equally. Now verifying the condition of an exact. So this is the condition of an exact. Del m over del y must be equal to del n over del x. Then we multiply y a function that is an integrating factor. So here putting the value of del m over del y, this equal to del n over del x, this. So now equating the coefficient of the power of, here we check this. In this term, the power of x to the power h and y to the power k plus 2 in this term, and x to the power h plus 2, y to the power k here. Same power is same in right hand side. Left hand side is power of x to the power h and y to the power k plus 2 in first term, and in right hand side same power in first term of right hand side. Now second term of left side, x की power h plus 2 and y to the power k. Similarly same power in right hand side of the second term. So here if two terms are equally left side and right side but powers are same, then we are taking the coefficient of the power equal. Then these results making equal. So now equating the coefficient of the power of x to the power h, y to the power k plus 2 and x to the power h plus 2, y to the power k in equation number 10 on both sides. We are taking the coefficient of this and coefficient of this on both sides. Then we get, so here k plus 3, we are taking here k plus 3 equal to, in this side 2h plus 1. So we get here 11 equation. Next here minus 2k plus 1 equal to minus h plus 3. So minus minus is cancelled. So with the help of equation 11 and 12, solving 11 and 12, we find the value of h and k. So simplifying equation 11 and equation 12, we get here. After simplifying means here k plus 3, this is the equation number 11. K plus 3 equal to 2h plus 2. K plus 3 equal to 2h plus 2. This implied that 2h, k taking right hand side, 2h minus k and 2 taking left hand side. So here 2h minus k equal to 2h minus k equal to 3 minus 2. So this equal to 1. So we get this equation 2h minus k equal to 1. Next from equation second equation is this minus 2k, k plus 1 equal to minus h plus 3. So minus minus is cancelled. So here is minus 2k plus 1 equal to minus h plus 3. So minus minus cancel. I am taking here. So 2k taking this side, h minus 2k and 3 taking this side. So here is h minus 2k equal to 3 taking this side, 2 minus 3. So this equal to minus 1. So we get here h 2k minus 2k equal to minus 1. So we get here equation 13 and 14. With the help of 13, 14, we find out the value of h and k. Solving equation 13 and equation 14 by cross multiplication or other method eliminating, cross multiplication or eliminating method. Both method we can apply here. Eliminating method. There are two methods solving two variable equation, ordinary equation, two variable with the help of cross multiplying and with the help of eliminating method. So we are applying here eliminating method. Multiplying. Now how we can solve? Any one variable, here one equation is 2h minus k equal to 1. Next equation is h minus 2k equal to minus 1. These equation. Here any one variable keeping equal. We are making this variable equal. So multiplying here 2. Multiply by 2 in 13 and subtracting 14. Okay. Then we find the value of h here. So multiplying by here 2, 4h minus 2k and subtracting this minus h plus 2k equal to 1 plus 1. So this 2k is cancelled. So here is 2h minus. So here is 2h minus k. So here 2k 4h minus 2k equal to h minus 2k. So 3h equal to 2, 4h equal to here 2, so h equal to here 1. 3h here 1, here multiply by 2k, so here is 2 plus 1 and here is minus h. So 3h equal to 3, so h equal to here we get 1. 4h minus 2k minus h plus 2k equal to 2 plus 1. So this 2k is cancelled. So here is 4h minus h 3h equal to 3, so h equal to 1 here. Next, now putting value of h in 13 equation. 13, which is 13? 13 is this 2h minus k equal to 1. Here we are putting value of h is 1. So after putting value of h is 1 here, 2h minus k equal to 1. This is the equation 13. Putting h equal to 1. Here h equal to putting 1. So 2 into 1 minus k equal to 1. 2 minus k equal to 1. And k equal to k taking this side, 1 taking this side. So k positive k equal to 2 minus 1. So k is also 1. So here we find h is 1 and k is 1 also. Both value are 1, 1. Now value of h is 1 and value of k is 1. So integrating factor x to the power h into y to the power k, that is x to the power 1 y to the power 1, that is xy. Xy is an integrating factor. Now we find out the integrating factor and multiply by this function to the given differential equation, then equation is an exact 100%. So now here, now multiply by this if is xy in 7, then we get this result. Xy, this equation first, that is 7. So here xy multiply here y cube minus 2x square y dx and plus xy 2xy square minus x cube dy. So after this is integrating factor. First, in starting the question, we are taking integrating factor as a x to the power h into y to the power k. Now at last we find out the value of h and k, then confirm the integrating factor is xy. So now multiply again xy in our question, then this question must be exact. So multiply by here xy into, so xy4 minus 2x cube by square and dx plus 2x square y cube minus 2 minus x4y dy equal to 0. This equation number 15. Okay. Now equation number 15 is an exact equation because this is the confirmed integrating factor. So here again, now equation 15 is an exact differential equation. Comparing 15 with this equation, m dx plus n dy equal to 0. Then we get again m. M is this result. M is x by to the power 4 minus 2x cube by square and n is 2x square y cube minus x to the power 4y. So this is equation 60. Now we are checking that this equation 15 is exact or not. Again we are confirmed that this is verify the condition of an exact. If this equation 15 verify the condition of exact, then we are confirmed that this equation is an exact. Then we apply the method of exact differential equation. So here m this and n is this. Now we differentiating m with respect to y and n with respect to x. Then we get del m over del y equal to here. Differentiating this result, del m over del y, differentiating this with respect to y. So y to the power 4 is function is y to the power 4. Differentiating with respect to y, 4y cube. y4, 4y cube. So 4x y cube and 2y square, differential of y square is 2y. So 4x cube by. So we are differentiating here 4xy cube minus 4x cube by del m over del y equal to del over del y. I am solving this question. So what is m here? M is y cube, m is xy4 minus 2x cube by square, 2x cube by square. So differentiating with respect to y, here 4y cube x minus y square, differential y square 2y, so 4x cube by. Now derivative of n with respect to x, so del over del x of, what is x here? X we are checking here, 2x square by cube, 2x square by cube minus x 4y, minus x to the power 4y. So differentiating this with respect to x. Differentiating with respect to x here, y as a constant. So here is 4xy cube minus here x4 into y. So x4, differential of x4 is 4x cube is y. So that is del n over del x. So both result is 4xy cube, 4xy cube, 4x cube by 4x cube by. So here del m over del y equal to del n over del x. So given equation 15 is an exact 100%. Okay, we checked our question after multiplying integrating factor. Our differential equation is 100% exact. So now we apply formula in this question, exact formula. So what is an exact formula? Using formula for solving exact differential equation 15. Formula, what is formula? I am writing here formula, integrating m dx. M, what is m? And last equation, after multiplying by integrating factor, in last equation we are taking m. Integrating with respect to x dx, y as a constant plus n, integrating n with respect to y. Here this is the condition here, for n this condition, for m this condition, for m y as a constant, for n taking terms in n not contain x. We are taking only those terms in n which not contain x, means x is not present in a term, we are taking only that term. Mean that term we are taking only which is separate y. X is not multiply by y only alone. So this equal to C. This is the formula of exact differential equation. So now I am putting totally value by m. I am putting here total value of m. I am writing here. So x by 4 minus 2x cube by square dx. This is the total value of m here. We are keeping y as a constant in this function. Y as a constant plus in our question n. In n is this function. Here each function have x value, not y separate here. So we are not taking any term from n. In our method, we are taking in n those terms we are taking not contain x. We are taking in n only those terms which have not contain x. तो इसमें ये both terms have x, so we are taking in place of n is 0. So here n is equal to 0, dy equal to c. So now integrating this term, y is constant, so y4 taking out of the integral, integration x dx and 2y square here. Second term is 2y square here. 2y square is constant here. So taking out of integral and x cube is dx. X cube is function. So x cube dx. This is 0. So totally this integral 0 equal to c only. So here multiply x dx means x square by 2. And x cube dx x4 by 4. So integration of x dx equal to x square by 2. And integration of x cube dx, this is x4 by 4. These are the integral of this function. This function we have. Now y4 x square by 2 minus 2y square x4 by 4 equal to c. So here taking LCM here. We are taking here LCM 4. So here is 2 y4 x square minus here already 2 y square x square equal to c. So 2 is common. Now finally answer is y 4x square minus y square x4 equal to c. Constant term goes in constant. Okay. So this is final answer. So what here we learn from this question means any question is given to me that is not exact. So now we are making exact by considering some function that is an integrating factor x to the power h and y to the power k. So h and k are unknown here. If we multiply by this function in our given differential equation, then our differential equation must be exact and verify the condition of exact. So at last I am verifying the condition of exact. Then del m over del y, value of del m over del y equal to del n over del x, we are putting equal to, then we get the value of h and k here. After finding value of h and k, then we confirm that integrating factor is known. Integrating factor is known, then again multiply by the known integrating factor to our differential equation, then differential equation must be an exact. Then we apply the formula of an exact, and after applying the formula we get the complete solution of a differential equation. So this is the procedure of this method. In this method we have find the solution. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.